My name is Zach Casper. I'm a product manager on the Incubations team, and been working on Radius for quite a while. I've been on a few of these community calls before, but let's make this as interactive as possible. I think everybody's on mute, so but that doesn't mean you can't talk or raise your hand during the call. We'll unmute you. We have a lot of people from the Radius team on as well, so feel free to get them in the chat. I'm sure a lot of folks can answer your question in the chat as well, but feel free to raise your hand and ask a question along the way. This call is going to be a little bit different than previous ones. We have a special guest speaker, Mark Russinovich. I'll turn it over to him in just a second. This call is going to be all about one really big new feature capability of Radius resource types. We're super excited for you to see it. We've been working on it for quite a while. So we're going to skip all the normal general announcements and pleasantries and really dive straight into it. At the end, we'll wrap it up. I'll give you some links to all the material that you're going to see here today. But we want to just hand it straight on over to Mark, and we'll just get straight into it. So Mark, do you want to take over the presentation? Sure. And thanks for joining. Looks like we got a lot of folks on the call, so I think a lot of folks are excited to hear from you.
All right, well, thanks, Zach, and hi everybody. Thanks for joining. I'm really excited today because Radius is kind of going through a relaunch, and before I get to what that relaunch actually looks like, I wanted to just share some background on the Incubations team and how we got to where we are with Radius. For those of you that might be new to it or not familiar with the backstory of what we're trying to do. So the Incubations team that I've got here in the office of the CTO is kind of an accidental one. It started with some technical assistants, Yaron Schneider and Hashi Bai, who saw some gaps in some open source technologies and decided to fill them. The first one was a scale to zero autoscaler for Kubernetes. And so Yaron took it upon himself to write one, and that eventually became Kata, the Kubernetes event-driven autoscaler, Kata, that we contributed to CNCF, and proud to announce that, or mention that it became a graduated CNCF project in August of 2023. That graduated actually into the developer division here, which runs our application platform teams like ACA and web apps. And so they maintain it on behalf of Microsoft's participation with that open governance. But at the time, back in 2019 or so, looking at the open source landscape, I saw two gaps. One, the fact that when you are writing a cloud native application, you've got to import probably a dozen SDKs if you're writing anything mildly complicated from across a bunch of different services to interact with different cloud resources. And if you're worried about multi-cloud, which most of our enterprise customers are, then that means that your developer teams are actually learning SDKs from different cloud providers to perform almost the same thing. So working with Yaron and Hashi, we came up with the idea of a sidecar that could provide an abstracted API that could then map to underlying concrete APIs for specific cloud services or even Kubernetes services. And some of you might be familiar with Dapper because that's what that project became, the distributed application runtime, which is based on the sidecar pattern of offering this abstract building block APIs through HTTP or gRPC. That also, I'm proud to mention that graduated in CNCF in November 2024. And really, both of those represented the core principles of what we were trying to do, which is to uplift the entire cloud native ecosystem. You can see both of them went into CNCF. Both of them are multi-cloud or Kubernetes based, which is inherently multi-cloud. And that is in response to the recognition that enterprise customers, when I go talk to them, cloud native equals CNCF. Most of them, when they're going to pick a cloud native platform, they want to make sure that it's got open governance, that they're not being locked into a particular cloud environment because they've got to worry about on-prem or other clouds. And so that was kind of the core principles now that set us up to have a formal incubations team. Dapper, when we graduated that also went into developer division and maintains it on Microsoft's behalf, and it's incorporated in a variety of Microsoft services. Now, at the same time, that we identified the gaps or the ways that we could improve the productivity of enterprise developers as they program their microservices. We also saw gaps in the way that they define their microservices or their cloud native applications. Most of these cloud platforms, whether it's Kubernetes or ARM and Azure, tightly bind the infrastructure with the application model. There's no separation. When you're talking about cloud resources, those are concrete. And that means that if you write to one control plane, that you're not portable across other ones. And again, you run into the same issues that we saw with Dapper, where you've got to learn a whole bunch of different types. And if you're moving the application around, you've got to port those types and create different deployments of those applications. Furthermore, there's little ability for a platform engineering team, which we saw a rise of these platform engineering teams, these groups inside of enterprises, which were defining a platform for their developers to use to implement various policies, whether it's security or compliance or cost management, because again, they've got to go mess with the application definitions, because that's where those controls are all, and those properties and constraints are all implemented. So we saw an opportunity to create something for applications. And I'll come back to that story in a second, because that kicked off the Radius journey. There's a couple of other incubations that I'll mention before I continue the Radius journey. One of them is COPA. You can see there on the lower left. That one arose because we saw a gap in the way that enterprises, including Microsoft, patch containers, specifically the way that it's traditionally done because of the immutable nature of container image layers, is that if there's a vulnerability deep in a dependency stack of images, you've got to go rebuild the entire stack of images up to an application layer before you can get an image that you can put in a registry and then deploy out to your production environment and get patched. And the big problem is that that adds a ton of latency, because these build pipelines for every image that depends on the one before it can be tens of minutes or hours even, or you might run into a situation where you can't get a build done because you're depending on a third party. So the idea behind COPA is that you can insert a patch layer directly on top of another one to provide a patch without having the entire stack to be rebuilt. And this is kind of similar to the way that traditional software patching is done outside of containers. That is being used in production at Microsoft now for several months, and we're patching literally millions of container images a month using that. And that was also contributed to CNCF and a sandbox project. And then finally, on the lower right, there's DRASI, which is a reactive kind of data processing system. There's nothing like it really out there right now, so it's kind of its own category. The basic idea there is that you can define standing queries. When those queries get satisfied, that triggers reactions. So you define sources, which are streams of events or events getting into DRASI. You define database queries on top of those events that represent what you want to be triggered on. For example, you want A to happen and B to happen at the same time. DRASI will then you can register a reaction for that can be emitting an event to a pub subsystem, for example, that you can respond to. And so that is also contributed as a sandbox project. So you can see that we've got a large portfolio here growing of CNCF projects and a lot of experience working with the open community and enterprises in bringing these things to market. Now let me get back to the Radius story, because that's the topic for today. Like I mentioned, we saw the same gaps that we saw with Dapper, where developers, if you're writing something for AWS and some that you want to take to Azure, now you've got to redo the whole application template for ARM, or you use Terraform, which has its own limitations that we've seen customers run into. And even Terraform doesn't really have a separation between an application and the infrastructure underneath it. So we started an incubation called Hydra at the time. And Hydra kind of started with this idea, although we ran into a challenge, which was we were defining resource types from scratch. And you can see a lot of application models that get started go this path of saying, let's go create new types for everything. And at the time, we thought that was the only way to get something new that would be cloud neutral. We graduated that into the upstream team here in Azure, and they started working with Upbound, and that became Open Application Model, OAM, and eventually that became the core of what's now called Crossplane. So it's kind of an interesting connection between what we've done in Incubations and some of the other work that's happening in the open ecosystem. But when we looked at where OAM and then Crossplane were going, it really didn't satisfy the vision that we had in mind for separating an application from the infrastructure and being cloud neutral. So we reset the project, we renamed it Radius, and we started based on Bicep as the language for describing an application model. And the separation between the application and the underlying infrastructure, we decided that that would be based on something called recipes. And we wanted to make sure that Radius out of the box supported multiple clouds without anybody having to change the way that they define their resources in their application model. So we natively support you integrating in Bicep templates native resource types, whether they're Kubernetes resource types, AWS resource types, or Azure resource types. And of course, it would support other clouds like Google through something called a universal control plane. And what that does is have Radius just pass those types off to those control planes that own those types to go provision them. So you literally, at this point, with Radius's universal control plane, support for these different cloud control planes, and recipes, have a few things that fall out of that. One of them is that you can take an application template that consists of AWS, Kubernetes, and Azure resources, give it to Radius, and then have it deploy across all three of those different control planes, one application. With the support of recipes, you have this separation between the application definition and the underlying infrastructure. And the place where recipes come into play are by binding certain types of types to the environment. Of course, in the current iteration or implementation of Radius, the native resource types of AWS, Azure, and Kubernetes, there's no support for recipes. Those are just go native. But we introduced a couple of resource types that support going through recipes. And with recipes, that allows you to define the way that those resource types get provisioned, or the platform engineering team can implement how they get provisioned. I mentioned before that platform engineering teams are concerned about security, compliance, cost management, and this allows them to define recipes that implement their various controls for those resource types. Those two resource types, or the categories of resource types, are the open source portable resource types that include things like Mongo, Redis, RabbitMQ that have implementations across different control planes. For example, there's native support for MongoDB in Azure in a couple of forms, including Cosmos DB in AWS. DynamoDB supports some MongoDB API. Azure Redis Cache is an example of a Redis implementation, although you can deploy Redis on Kubernetes using containers. And then the second category of resource types that support recipes are Dapper resource types. We wanted to make it so that Dapper and Radius work great together. And if you define an application using Dapper resource types with the code written using Dapper sidecar APIs or building blocks, what you end up with is a completely portable application that you can take without modifying the application or the code of the application and deploy it to different environments. Now the recipes, which get invoked by Radius when it sees a recipe registered for one of these resource types, can be implemented today in either Terraform modules or Bicep. And that means that you can define Bicep templates if you're familiar with Bicep and want to take advantage of its infrastructure as code language, including all of the rich tooling support it's got. Or if you've got existing Terraform recipe or Terraform modules and you built a lot of your infrastructure up with Terraform, you can go ahead and take advantage of those to go deploy them. And then the final concept in Radius is this concept of environments, where an environment is really effectively a landing zone for an application, where recipes are registered to an environment. And so if you are deploying to your own test environment or your development environment, which could be even your own dev box, you can have recipes that go and instantiate, for example, MongoDB as a container. And if you're deploying it to a production environment, it might deploy it and the recipe might stand up Cosmos DB to implement the Mongo API. So this achieves that full vision of separation between the application definition and the platform, at least for these open source and dapper resource types. But what I'm thrilled about announcing here today is that we're extending the support for these custom resource type, or these resource types that support recipes by defining custom resource types or radius resource types. And this truly is the killer feature. And let me explain how this feature came about. It really was driven by some of the customers that we have that are already working with Radius and deploying it to production. And some of those enterprise customers have internally defined their own platform application models where they've defined their own types using their own systems that it consists of Helm charts, for example, where their developers are given a type like a Postgres database that defines how the enterprise wants the Postgres database to behave for certain types of applications. One of our customers, for example, has a concept of a database that can fail over between regions, but the developers don't have to worry about that. They just instantiate one of these types of these databases, and underneath the hood, the templates that the platform engineering team has defined go and stand up those failovers across regions. So they came to us and said they love Radius, they love the separation between the application and the environments, but they want the support for defining their own, that support their own flavors of things that they want to present to their developer teams. And so we looked at how we could implement that and extend recipes beyond those resource types, and have come up with this idea now of these custom resource types. And we're going to be extending that even further, because one of the things that we want to support is where you can just have a template that has an existing cloud resource type, like cloud control API resource type for AWS, or a bicep resource type, ARM bicep resource type for Azure, and implement a recipe for that, where you might want to say, for example, extend that resource in some way when it gets deployed into a Radius environment, again, using Terraform or Bicep. So you can completely override the implementation effectively of one of these types that exist for one of these cloud control planes. And with that, we really even went back and said, does Radius even need built-in types? Can they also be implemented internally in Radius using recipes, and then customers can come, users can come and override those with their own recipes? And so that's really what we've gone to, is now completely, almost completely decoupling the concept of a type from a concrete implementation of the type, and made them all flexible through this recipe support. So and I've got some cool examples here of this, but really this is, I think, a big breakthrough in our kind of thinking. Again, it's kind of cool, driven by customers to think and stretch what we were doing with Radius to support this kind of flexibility, because at this point, now this control plane of Radius, it lets you find an application that's completely portable across clouds if you want them, or implements whatever custom policies or even whatever custom types your platform engineering team wants to implement, to make it really easy for your developer teams to just fall into the pit of success and do the right thing. So I've got some cool demos here that I'm going to show you. One of them is defining a Postgres type, which Radius doesn't have the concept of a Postgres type. And so the platform engineering team here in this example is saying they want to provide a Postgres resource type for their developers, but they want to control just about everything about the Postgres database implementation. The only knob they want to give developers is the size. so the developer can decide whether it's small, medium, large, or extra large. And you can see the properties there on the left. And the read-only properties that are available to the application developer, you can see there on the bottom left, the database string, the database name, the host, the port, the username, password, which are necessary for the application to actually make use of that Postgres database. The platform engineering team, though, implements a recipe. And in this example, the recipe is going to be a Terraform module. And that Terraform module is something that maybe the platform engineering team already had from their use in their implementation of Postgres outside of Radius. But now that they've adopted Radius, they want to define this resource, Radius resource type, make it available to the developers in Radius, and then support 2 deployment versions of that resource, one into a test environment and a production environment, where you can see that the only difference there is the parameter production equals true. So let's go take a look at that here in a second. And I'm going to come back to this here and talk about it in a second. But let me go ahead and show you this creation and deployment of a Postgres resource type. So if I do rad resource type list, you can see here all the resource types that have been registered for Radius. And I'm going to go ahead and create the Postgres resource type here. And it's based on a Terraform module, like I said. Now, when I list again, you can see that that resource type now has been registered with Radius. And now it's available for developers to deploy into their environment. And if I register that resource type here as the platform engineering team into the test environment and into the prod environment, now we have a version of that resource type deployed into the prod environment with production equals true, like I mentioned. And at this point, the application developer can go ahead and leverage that resource type here. Here's Postgres. Here's the name of the DB that they're giving it. And the property, like we mentioned, you can see all of this autocomplete provided here in VS Code through the extension because it's aware of the type. And you can see the supported values of small, medium, large, extra large. In this case, it's going to be a medium-sized database. And now we're going to set up a connection. As those of you familiar with Radius are aware of connections, connecting that container to the Postgres database, which Radius uses as it's deploying to know that it needs to create the database first. And you can see there's the database creation. Here's the container deployment. And now when we look at that deployed application, you can see the resources, including those dependencies that application container depends on that database, and that database is there fully deployed. So that is an example of Postgres Radius resource type. Again, defined completely by the platform engineering team with that one property that developers are allowed to set. Now, that was really cool, but I want to show you something even cooler, because what you can do with these recipes is there's no limit to how complex the resources underneath a Radius resource type is. So one of the examples that we've seen a lot is the platform engineering team wanting to say, hey, we'd love a container resource type, but it needs to have an ingress controller in the front of it. And we want our developers just to be able to specify a container type, automatically gets that ingress controller attached to it without the developer having to go define what that looks like. Because they're not just interested, they're just basically saying they want ingress for this container. So this is an example of a composite recipe that consists of multiple underlying resource types to implement a Radius resource type that is provided to developers. In this case, it's a web service. You can see there's a test environment that has a recipe registered for it in it, and that recipe for this resource type in the test environment uses a bicep template that consists of 2 resources, or it can use one of them is a Terraform resource, and the other one is a bicep resource. So this case lets you compose Terraform modules, bicep templates into an arbitrarily complex implementation for types. And let's go take a look at a deployment of that ingress controller resource type here. So here, you can see this is the web service bicep template. There's a couple of types in here, like we mentioned. There's the resource gateway type, and that's going to be set and created only if the property on the Radius resource type is set to ingress equals true. And then there's a container resource type, which is just passing through to the underlying Radius container resource type. So that means when somebody goes to deploy this, and let's go create register that type. Here's the web service type, registering. And now we're going to go register the recipe that we just looked at into the test environment. And now we're going to, instead of using our standard Radius container, we're going to use our new web service resource type. We're going to specify that we want ingress. And at that point, we've got a template that when we go deploy it, it's going to automatically go create that ingress controller using the underlying bicep template for it, as well as the underlying container. And there you can see it. There's the connections, there's the resource type, there's a container and the gateway attached to it. So that brings me to the conclusion of presentation on this really cool new capability, these resource types. You can think of them as custom resource types, but really it's just, we're debating over the name, thinking, should we call them custom resource types? No, you know what, really they're just Radius resource types, because every type in the Radius system now will have or has support for recipes. And so none of them are really custom, they're all customizable. So let's just call them Radius resource types. And so that's what we thought was so exciting to have a special community call. We almost view it as a reboot of Radius with this new capability that provides flexibility that you don't see in any other infrastructure as code system, on top of the capabilities like the graph and the recipes that Radius brings to it. So with that, let me go ahead and turn it back over to Zach.
Yeah, thank you very much, Mark. So if everybody is interested in seeing this more in action, we invite you to try it out. Both of these demos that we gave are straight off the tutorial. So go visit the docs page. The docs are live. You can walk through it. It walks you through, both the Postgres and the web service examples. So that's the majority of the content for today. We open up for Q&A. Just raise your hand. We'll unmute you. Feel free to put something in the chat as well. But that's all the content that we have. Who has the first question? All right, y'all are quiet. Well, I do think you'll have a lot of questions if you go through this tutorial. All right, we have one from Matthias. How does it work with the Terraform state if it's built on Terraform? Okay, so today the Terraform state is, we use the Kubernetes Terraform state. It is essentially a separate Terraform state within Radius itself. We have a roadmap item that's relatively high priority of being able to customize the Terraform block. So you essentially customize your own, you can specify your existing Terraform state. But today that state is just within Radius. All right, Nick, will the new resource types allow us to remove the dependency on Contour? So today, the gateway resource type uses Contour as an ingress controller, and when you install Radius, the Contour daemon set Envoy gets applied as well. So number one, today with Radius resource types, you could create your own gateway type. You can call it My Gateway, or some other, if you want to use Nginx or something like that. So you can absolutely go and implement a different ingress controller other than Contour. In the future, we've already we've already provided one build of Radius that had contour disabled. So we may, open to feedback here on what would work best for you. We may have an option to disable the contour if it's not going to be used. We want to have a good out-of-the-box experience with the gateway, so we're trying to figure that out. But yeah, in the future, we want you to be able to use whatever ingress controller you want. All right, Luke, can you show the type definition YAML file? It is in the tutorial. If you click on the link that Reshma just added, you can see the Postgres one. That's included in the doc, and then you continue into the composite recipe, and there's just a link there because that web service schema is a bit more complex. But the key thing you need to know is it's an open API schema. So all the things you're used to seeing. If you're familiar with doing a Kubernetes CRD, it's an open API schema. So there's really, you can put whatever you want, pretty much whatever you want in that schema. Any plans to support OpenTofu? No specific plans. We don't have that on the roadmap. It's been brought up a couple times. We're interested in feedback there if we need to support that. We call it the recipe driver. So we support Bicep and Terraform today. That's an extensible model. In the fullness of time, we want to support really a wide range of IAC solutions. Radius is very unopinionated about what IAC you use. So OpenTofu would is totally on the table if there's demand to do that. All right, Jeffrey, how does Radius handle shared infrastructure for recipes? If I want to use a shared application gateway, for example, used by multiple teams. Okay, so two options there for shared infrastructure. Number one, you can pre-provision these things. So for example, if you want to have a pre-provision an application ingress controller on your Kubernetes cluster, that's totally fine. That'll be pre-existing. It's essentially outside the scope of Radius. Same thing, for example, if you wanted to do a horizontal pod autoscaler, for example, you can just set up an HPA, outside the scope of Radius. However, we do have, and I can share a sample if you're really interested in this. What you can do in Radius is have an environment that has a resource already deployed to it. So maybe a better example would be like a shared database. So you can have an environment with a shared database that was pre-provisioned by the platform engineer. Then your developer can, within their application definition, reference that shared database by name and get the properties for it, like the connection string, the username, the password, for that shared database within that environment. So the developer could basically just reference by name that pre-existing resource. All right, and y'all chime in if I'm burning through these. Y'all chime in if there's follow-up questions. Reshma's example, is there plans to present recipes through the Azure portal like an internal developer platform? So no specific plans around Azure portal. However, Radius does have a dashboard. It's built on Backstage. And in the Radius dashboard, today you can see the environments, you can see the resources, you can see the applications that are deployed, you can see like a nice visual graph of all of the application components. We do plan to put the list of resource types and those resource type properties in the Radius dashboard. You can think about this as the developer documentation. Today, in the quick demo, you may have seen, it was very fast. Rad resource type show, and it listed all the properties that were required, the ones that are read-only, that kind of detail, and like the description that the platform engineer put in for that property. Those details will be browsable in the Radius dashboard in the future. Let's see. Can we run control plane separate from the application cluster? So no, today when you deploy an application and if you deploy to Kubernetes, that Kubernetes is the host Kubernetes cluster that is running the Radius control plane. That's today. We have some other users that are actively looking at implementing the ability to target a separate destination Kubernetes cluster. And the way that those discussions are, think about it as a kube config that's part of the environment specification, right? And so if you deploy to this environment, that environment has a kube config property that has, your target Kubernetes cluster as well as the credentials to deploy to that external Kubernetes cluster. And then you could just essentially deploy to an arbitrary Kubernetes cluster. And the idea being, Radius as really just a control plane as a mediator between different deployments, being able to deploy. Obviously you can already deploy to separate Azure subscriptions and resource groups. It's just natural to support another Kubernetes cluster. I'm losing track. These are great questions. Can we import existing infrastructure to a Radius-based setup similar to Terraform's import functionality? I don't think the brownfield is a short answer. There's things you could do. We have some support around ratifying existing Helm charts. But I'd love to talk to you about how brownfield and kind of importing existing applications into Radius, how that should work. One of the things that Mark mentioned which is a really fascinating idea is, we do want to extend the ability to specify a recipe for an existing, say, Azure resource type. So if you had a developer with a bicep file asking for a Cosmos DB, using Radius, you could override that request for Cosmos DB with your implementation. So essentially, maintaining the existing, application specification, including the Cosmos DB, but the platform engineer being in control about how that's actually deployed. Luke, on the slides, yes, I think we will publish the slides. Sure, yeah. We publish these calls on YouTube, and we'll put a link in the description for the slides. Yeah, so Nick is the one looking into multiple Kubernetes clusters. Okay. Odie, I think I missed the answer to this one from Jeff. Is there plans to be able to present recipes through the Azure portal? I said no specific plans on the Azure portal. I did mention a little bit on the Radius dashboard, which is a backstage plugin. That's where we plan to expose the resource types and resource properties. And Jeffrey, not sure if anybody's aware of this. Okay, yeah, KRO, yeah. Is there explanation about KRO and complementary to one another? Yeah, they're pretty separate. I think one of the key difference between a lot of the Kubernetes exclusive solutions like Crow, we're with Radius, we're very focused on, obviously we're deploying applications to Kubernetes, but we're really also focused quite a bit on all the other non-Kubernetes resource management. So you hear us talk a lot about Postgres and Cosmos and DynamoDB, and I think our view of the world is the reality is not everything runs on top of Kubernetes, and so I think they're complementary. Crow and Crossplane, and I imagine in the fullness of time, Radius really integrating in with all those Kubernetes exclusive tools. But Radius is a bit different than those others because we are focused well beyond just Kubernetes and really just using Kubernetes as a runtime.
Can I just jump in here, Zach? Because one of the original vision for Radius and Dapper was to go towards a serverless world where developers and even platform engineering teams aren't worried about Kubernetes and cluster management, but really the platform takes care of deployment of the containers and the management of those containers, kind of like functions as a service, really going to serverless. And so one of the things that I demonstrated I've demonstrated previously is deploying Radius applications onto ACI, Azure Container Instances. And so that is really kind of the future vision for where I think things will go, which is onto a serverless platforms where Kubernetes is not really in the picture, except maybe as an underlying infrastructure that is implementing, is underneath that serverless container infrastructure. But that said, we're meeting the world where it is right now, and so want to make sure that it works great with Kubernetes.
Yeah, and we demoed using Radius, deploying an application to ACI at the last community call. So I invite you to check out the YouTube recording for that. You know, the fullness, you know, on the serverless side, especially like honestly, like everybody could do this today. You could definitely write you could create a Radius restore type for a function, give it a Terraform or Bicep recipe, and deploy on top of Lambda, deploy on top of Azure Functions. I haven't done that myself quite yet, but I mean, it's a very extensible model. So if you could deploy it with a Bicep or Terraform module, you can deploy it with Radius. You know, so I imagine just the flexibility in terms of compute and, you know, compute extensibility, you know, it's well beyond just Kubernetes. All right. Okay, y'all are brainstorming. Okay, those are good ideas on the brainstorm. These are amazing questions, so please keep them coming. If you know, feel free to raise your hand. I'm going to just cover a couple of other kind of closing points here, but if anybody has additional questions, you know, we have time. Just a couple of final reminders here, and again, if you have more questions, you know, chime in. But the best way to get a hold of us, everybody on the contributor team here is active in Discord. That's the best way to get a hold of us in real time. We do have an email distribution list. It's a Google Groups. It's pretty much the only traffic there is reminders of this call. So I encourage you to at least sign up on the Google group just so you get a reminder about this call. It's a monthly call. And we do have a Radius blog, and we've posted quite a bit of platform engineering type topics lately. So I invite you to check out blog.radapp.io. It's, of course, on the Radius website as well. So that's all the reminders. Any final questions? Otherwise, we can wrap it up. Okay. Well, I thank everybody for joining. It's been really excited, and thank you very much, Mark, for joining. It's great to hear the history of Radius, and you know all the. It's always fun to hear about Ohm and all this, like how things work, and how things come back around. Yeah, but thank you very much, everybody. If you have more questions, find us on Discord. This chat will be open for a bit, and I would love to hear how you're planning on using Radius. So thank you so much.
Yep. Thanks everybody for your support and partnership.
Thanks all.
Bye-bye.